So this trig rearranging involves a lot of the double angle formulae. So before we start, let's just make sure that we're okay with those. In our formula books, it has sine of a plus b, and if we put the same angle in for both of those, we can deduce that sine of 2 theta is equal to 2 sine theta cos theta. That's going to be useful to substitute in here. And also cos of 2 theta, that gives us cos of theta minus sine of theta, which is cos squared theta minus sine squared theta. And then I can use the fact that sine squared plus cos squared equals 1. If I substitute that in for the cos squared, I get one thing, and if I substitute it in for the sine squared, I get another thing. So I can rearrange this and have 1 minus 2 sine squared theta. I can also have 2 cos squared theta minus 1. And I'm going to use those in different places here. So I'm going to use this one in the numerator and this one in the denominator, I think. Right, so let's get started. We've got 1 minus cos 2 theta plus sine 2 theta all over 1 plus cos 2 theta plus sine 2 theta. So up here, I'm going to substitute in 1 minus 2 sine squared theta in for this cos 2 theta. And then in for the sine 2 theta, I'm going to put 2 sine theta cos theta. And then the denominator, I'm going to use the 2 cos squared theta minus 1 in for this one. And I've chosen this because I can see that the 1's are going to cancel nicely. And also I'm after a tan in the end, and then I'd have a sine squared over a cos squared, which seems quite useful. Okay, already that's looking quite nice because I can see that I've got the same on the top and the bottom there. So these 1's, 1 minus 1 is great, and 1 minus 1, that's helpful. So if I just write this out nicely, I've got 2 sine squared theta plus 2 sine theta cos theta all over 2 cos squared theta plus 2 sine theta cos theta. Now if I factorise, I can take out a 2 sine theta on the top and be left with sine theta plus cos theta. And I can take out a 2 cos theta on the bottom and be left with cos theta plus sine theta. So they cancel, and I'm left with sine over cos, which is tan theta, as I was hoping for. Now part B, it wants us to solve this equal to 3 sine 2x. Now this is just this, but with 4's instead of the 2's. So it means that this is equal to tan of 2 theta. So tan of 2 theta equals 3 sine of, well, I should have used an x there, they've used x's. Tan of 2x equals 3 sine of 2x. So I'm going to write this tan 2x in terms of sine and cos. That's sine of 2x over cos of 2x. And I think if I multiply by cos of 2x, I can then take everything to one side and factorise. It's going to be nice. So I've got sine of 2x, and I'm going to subtract this. Sorry, I'm slightly off the page there. And now I'm going to factorise. I've got sine of 2x as a common factor. And I'm ready to So sine of 2x equal to 0, that would give me 2x is 180, so x is 90. That would be one solution because it just wants the solutions between 0 and 180. And then 1 minus 3 cos 2x equals 0. So cos of 2x equals a third, and 2x is equal to 35 point, no it's not, is equal to 70.52. And if I find the other solution at the moment, it's 289.4. And then if I divide everything by 2, so just find x, then I get 35.3 and 144.7. I always think it's good to find all the solutions at this point outside of the range and then divide at the end.